Example 2. Using mesh analysis, determine the currents of the network. Now, in this particular network, there is a current source involved. So, we cannot approach to solve this type of circuit by using the general mesh analysis. This is because when we apply Kirchhoff's voltage law across each closed loop, we need to know the voltage or potential drop across each element. But in this case, we do not know the voltage across the current source. Hence, we cannot solve this circuit using mesh analysis. As a result, we will approach this circuit with super mesh analysis. The first step remains the same as we have done in mesh analysis. That is, we need to identify the number of closed loops and then assign a distinct current to each of these loops in the clockwise direction. As you can see over here, I have assigned the current I1 in loop 1 and the current I2 in loop 2, and both of these currents are in the clockwise direction. The next step includes the indication of the polarity across all the resistors. Now, in the third stage, we need to deactivate the current source with an open source equivalent. One thing which you must remember is that you are not physically deactivating this current source. You are just assuming that the current source is deactivated by an open circuit equivalent. Then we apply KVL law across this super mesh. So, applying Kirchhoff's voltage law gives, for loop 1, we are moving from negative towards positive, so plus 20 volt. Then for across R1, we are moving from positive to negative, thus minus I1 6 ohm. For R2, again we are moving from positive towards negative, thus minus I1 4. Then for R3, we are moving from positive to negative, so minus 2I2. And for E2, we are moving from negative towards positive, thus plus 12 volt. And the summation of all these will be equal to 0. Thus, we get the first linear equation, which is 10I1 plus 2I2 is equal to 32. Now, over here, there are two unknown variables, I1 and I2. So, we need to solve two linear equations to determine the values of I1 and I2. One of the linear equation is this one. And the other linear equation we will get from here. The resultant current flowing through the current source must be equal to the difference of the currents I1 and I2. Now, the direction of the current I1 through the current source is downward and the direction of the current I2 through the current source is upward. The resultant current through the current source is downward, 4 ampere. Thus, we can assume that I1 is greater than I2. Hence, I must be equal to I1 minus I2, which is equal to 4 ampere. So, the second linear equation will be I1 minus I2 equals 4. On solving these two linear equations, you can easily determine I1 and I2. Example 3. Using mesh analysis, determine the currents for the network. This network has three closed loops, that is loop 1, loop 2 and loop 3. So, we have to assign three distinct currents to each of these loops in the clockwise direction. Hence, the current assigned in loop 1 is I1, current assigned in loop 2 is I2, and current assigned in loop 3 is I3. The next step is to indicate the polarity across all the resistors, which is shown over here. After that, we have to replace each of these current sources with their open circuit equivalent, which is shown over here. Now, as you can see that there are three unknown variables, I1, I2 and I3. Therefore, we will need three linear equations to determine their values. If we consider loop 1, then the current flowing through loop 1 is I1. Over here in this branch, I1 is the only current which is flowing. Thus, I1 is equal to 6 ampere. Since the direction of I1 and the direction shown over here in the current source are equal or in the same direction, thus I1 will be equal to 6 ampere. For loop 3, I3 is the current flowing through this branch. Thus, I3 is equal to 8 ampere. Now, we have already determined 2 among 3 unknown variables. So, we only apply Kirchhoff's voltage law KVL in loop 2. On solving this linear equation, we can easily determine the current I2. So, the current I1 will be equal to 6 ampere, current I3 will be equal to 8 ampere and current I2 will be equal to 4.75 ampere. Example 4. Find the current through the 10 ohm resistor of the network. That is, for this particular network, we have to determine the current flowing through this 10 ohm resistor. So, the first step is to identify the number of closed loops in this circuit. Over here, we have 3 closed loops, that is 1, loop 2 and loop 3. Next, we have to assign 3 distinct currents to 3 of these loops. The direction of the current will be in the clockwise direction. So, I have assigned I1 for loop 1 in this direction, I2 for loop 2 in this direction, I3 for loop 3 in this direction. The next step is to assign the polarity of the resistors with respect to the direction of the currents for each particular loop. So, if we consider loop 1, I1 is entering through this terminal, coming out of this terminal. Therefore, this is positive and this is negative. I1 is entering through this terminal, leaving through this terminal. Thus, this is positive, this is negative. Considering loop 2, I2 is entering through this terminal, coming out of this terminal. Thus, this is positive and this is negative. I2 is entering through this terminal, coming out of this terminal. Therefore, this is positive and this is negative. I2 is entering through this terminal and leaving through this terminal. Therefore, this is positive and this is negative. Considering loop 3, I3 is entering through this terminal, leaving through this terminal. Therefore, this is positive and this is negative. Again, entering through this terminal, leaving through this terminal. Therefore, this is positive and this is negative. I3 is traveling through this way through resistor of 10 ohm. Therefore, this is positive and this is negative. If you observe carefully, the current flowing through the 10 ohm resistor is basically I3. So, if we determine I3, then we will easily say that the current flowing through the 10 ohm resistor is I3. Now, the next step is to apply Kirchhoff's voltage law in each of these loops. So when we apply KVL in each of these loops, you need to remember one thing very carefully. That is, when we are considering loop 1, the current flowing through the 8 ohm resistor is the resultant of I1 and I3. So when we consider loop 1, we will consider I1 is greater than I3. Therefore, the resultant current flowing through the 8 ohm resistor is I1 minus I3. For the 3 ohm resistor, the resultant current flowing through the resistor will be I1 minus I2 when we apply KVL through loop 1. However, when we apply KVL in loop 2, the resultant current through the 3 ohm resistor will be I2 minus I1. Now we have to consider I2 is greater than I1. The resultant current through the 5 ohm resistor will also be I2 minus I3. However, when we consider loop 3, in that case, we will be considering I3 is greater than both I1 and I2. After applying KVL to each of these loops, there are three equations that you will get are these. On solving these three linear equations, you can easily determine I1, I2 and I3. I3 will be equal to the current flowing through the 10 ohm resistor, which is equal to 1.22 ampere. Example 5. Use mesh analysis to determine the three mesh currents in the circuit. So, for this particular network, we have to determine the three mesh currents. The mesh currents are already assigned. So, based on the direction of the current in each loop, we will indicate the polarity across the resistors. The next step is to apply KVL to each of these loops. On doing so, these are the three equations that you will get. On solving these three equations, you will be able to determine I1, I2 and I3. I1 will be equal to 3 ampere, I2 will be equal to 2 ampere and I3 will be equal to 3 ampere. Mesh analysis with dependent voltage source. The approach to solve this kind of problem is the same as we would have taken for an independent voltage source. The solution for this particular problem is given over here. Please go through this solution very carefully. Mesh analysis with dependent current source. In this particular network, we have one independent voltage source, one independent current source, and a dependent current source. Over here, we have 4 closed loops. Thus, we need to assign a distinct current in the clockwise direction to each of these 4 loops. Now, after assigning or indicating the polarities of the resistor, we need to replace these 2 current sources with their open circuit equivalent. And then we must assume these 3 meshes to be a super mesh and apply KVL. Since there are 4 unknown variables, therefore you will get 4 linear equations to determine I1, I2, I3 and I4. The solution to that problem is given over here. On solving those 4 equations, you will be able to determine I1, which will be minus 7.5 ampere, I2, which will be equal to minus 2.5 ampere, I3, which will be equal to 3.93 ampere, and I4, which is going to be 2.143 ampere.